Okay, good morning. I'm going to be going through the notes on heat and thermodynamics, which is Unit 3. All right, so a little bit of review in our terminology. So, what is energy? We just got out of the energy unit, and energy is the ability to do work. So, chemical reactions require energy or create energy. Actually, all chemical reactions require energy to start, but they either end up storing energy or they end up giving energy into the environment. And I know we're in the physics portion of the class, and we're talking about chemical reactions right now. But just remember that physics and chemistry don't exist in their own separate bubbles, and both disciplines are a study of the physical world around us. So we kind of get intermixed with our study of physics and chemistry, as we probably should. Okay, heat versus temperature. So a few more terms you're going to need to know the definition to. So heat is not the same as temperature. Heat is actually a measurement of the energy transferred due to a temperature difference. So when think about temperature moving, or heat is the movement of that energy. So energy transferred. So maybe you could write in your notebook, heat is energy moving, whereas temperature is the measurement of thermal energy. So this is actually that measurement of what's the temperature of this system or this thing. And it can be measured using thermometers. So this is the measurement, and this is the actual movement of the energy. Okay, so thermal energy, something that has more thermal energy or more heat would be this red one on the left. So you see how the particles are moving faster. And then the blue one, where it has less thermal energy or less heat, the particles are moving slower. So heat and kinetic energy are kind of one and the same. The faster particles are moving or vibrating, the higher your heat. I'm sorry, the higher your temperature. And the slower the particles are moving, the lower your temperature. Now, there actually is a limit to how little particles can move. When particles stop moving, that's considered absolute zero, because obviously you can't move less than not moving at all, right? So that is about, or it is exactly 273.15 degrees Celsius, also known as 0 Kelvin. So Kelvin is another way to measure temperature, kind of like Celsius or Fahrenheit, and it uses the Celsius scale. So each it says degrees Kelvin here. That's incorrect. It's just 0 Kelvin. But every unit of Kelvin is the same as a degree Celsius. It's just zero would start at absolute zero, and water freezing, which would be 0 Celsius, would actually be 273.15 Kelvin. Okay, thermochemistry. So changes of heat um, and heat transfer. So remember, heat is energy moving. So energy likes to move from hotter to colder, and energy can't be created or destroyed. So this is just the movement of heat and it going from either one form to another or one location to another. All right, and then the three modes of heat transfer. So conduction is, if you look at the metal rod here, so the tip of the metal rod is heating up and it's starting to move the heat and the energy all the way up through the rod, just because the rod itself, the molecules of the rod are in contact with each other. So that is how the heat is moving. So kinetic energy due to contact. Convection, think of the phrase hot air rises. So hot fluids, when they get hot, they tend to dissipate. So they become less dense and then they rise, and then cold air or cold fluids, cold water would fall. So hot air around the fire would rise up. That's why if you put your hands like over a flame, that tends to be really hot. So convection, connect that to the movement of fluids, so liquid or gas. So generally solids would not participate in convection. And then radiation is the transfer of heat by electromagnetic waves. We haven't talked about electromagnetic waves here, but think of it this way. If there is nothing needed to be between the heat source and the thing that's getting hot, Like you don't even need air. You could just have, like, think about the sun and the earth. There's literally empty space between the sun and the earth, but the sun is heating the earth. That would be radiation. And remember, things are moving from hotter to colder. And this is called thermal equilibrium, where the entirety of a system and really the entirety of the universe is trying to balance out its temperature. So eventually, an entire system will eventually reach its thermal equilibrium here.